Hello everyone, my name is Umar. I'm from University of Iowa, and I'm here to talk about ad and tracker blocking. I will start with giving an overview of life cycle of an ad and tracker. So, ads are audio-visual promotion content. What you see here right at the corner is an image, but they are usually created with JavaScript, which results in an initiation of an HTTP request, and that results in a markup. So as a whole, both ads and trackers are a combination of JavaScript, HTTP, and HTML. In case of ads, the markup is the HTML around the ad image, and in case of trackers, it's mostly one by one pixel tag. So both ads and tracker here involve all three layers of the web stack, which are JavaScript, HTTP, and HTML. So now that we have looked at the anatomy of how ads and trackers work, let's see what existing filter lists use and how do they block these ads and trackers. So most of the filter list solutions use filter lists, which are crowdsourced. So users give their feedback, and then their feedback is translated to rules that blocks request at the HTTP level, hide the ad HTML elements, and stops execution of JavaScript. That helps those ads and trackers. So one important point to note here is that these solutions work at all these three layers, but in isolation. But previously, we have seen that all ads and trackers are like combination of these three layers. If they were to look at their whole context, they would have been much more effective. Secondly, this whole process is manually curated, which brings a lot of problems. First of all, priorities has shown that they are very slow. They take at long as like weeks and months to add rules for newly discovered ads and trackers. And secondly, priorities has also shown that they are redundant. They create thousands of rules, and only like 10% of those rules are used. And thirdly, they are error-prone. So slowness and redundancy makes this filter list underblock content, so they let some ads and trackers through, or overblock content, which causes breakage. So to address these two problems, in our research, we utilize the cross-layer rich contextual information to identify ad and tracking related patterns. So the basic idea is that we instrument a browser and capture the fine-grained interaction details of ads, the whole web page rendering, which involves the creation of element, attribute modification, script execution, request initiation, and a whole bunch of other stuff. So that whole fine-grained interaction details is modeled as a graph, and we see that these fine-grained interaction details are actually very useful, and the ad and tracking patterns stand out from the functional patterns inside those graphs. We then use existing filter lists to label those behavioral patterns and feed those behavioral patterns to a machine learning classifier. And from that machine learning classifier, we're able to identify patterns related to ad and trackers and functional content. One example of those patterns is that we saw that ads and trackers mostly interact with other ads and trackers on a web page, and they have their own less connected cliques, whereas the functional content kind of interacts with the overall page. So the key idea here is that we capture the context or the behavior of these ads and trackers and basically try to differentiate that and generalize it with machine learning. We are also planning to open source this implementation, which can then be applied to more specific problems related to ads and trackers and some other problems as well. And one example of that technique is it's used in fingerprinting. We are collaborating with Steven here at Firefox, and the idea is to use contextual information within a script, which could be its syntactic structure, and then its interaction with the overall page, which will involve how it's dynamically interacting with other content. Is it like sending requests? Is it interacting with the other content on the web page? So combining all that information, we have seen encouraging results, and we plan to move forward with this approach and have like more interesting results. Now I conclude and welcome questions about instrumentation or using these techniques into more specific techniques and anything about the presentation. Thank you.